Hello, hello. So we are back with our second video of the year, talking about balanced and unbalanced forces. I know that we have gone over this topic already for a little over a week, but I want to make sure that you guys really understand this topic before we move on to our next thing. So just like last time, you're going to fill in your paper with the stuff on the screen and try to listen to me because I think sometimes I have good information for you. Okay. Let's see if I can, there we go. Okay, so just to start, our essential questions are: what are balanced and unbalanced forces? And how do unbalanced forces cause a change in position, direction, and speed of an object? I'm not going to worry about having you guys mark your answers because you can't do that, but just keep those questions in mind. So first we need to talk about force. So a force is a push or a pull from one object to another. It may or may not cause movement. Depends on, the net force that we talked about last week, whether or not it creates movement. Gravity's force pulls downward towards Earth's center. So remember that gravity pulls things in, and air resistance pushes against moving objects. Applied force is when a person or object directly pushes or pulls another object. So it has to be directly against something that it's pushing. Normal or supporting force is a name for force that holds objects in place against gravity or other forces. So for example, in this picture, gravity pushes the book down. So gravity is wanting to pull that book down into the center of the earth, but the table pushes back up on the book. So like we learned last week, we would say these forces, the net force is 0 because as gravity is pulling with the same amount of force as the table is holding it up. So what is the normal force? In this example, the normal force would be the table. Okay. With you, your normal force would be your skeleton because it is holding you upright while gravity is trying to pull you down. So just quickly, we're going to go through these and look at the definitions. So we have balanced forces, unbalanced forces, and net force. So the first one is the overall force acting on an object expressed in newtons. I'll give you guys a hint. The color is a giveaway here. So that one is going to go over to net force. This orange one, when two equal forces act on an object in opposite directions, they are balanced. So the forces are equal, they're acting in opposite directions, so nothing is going to change. And then this pink one, when unequal forces cause an object to move, and so that would be unbalanced forces. But even then, in the slides, that's not a great definition, right? Because unbalanced forces just means there's a change. It doesn't mean that it's going to start moving or that it's going to move. It could be stopping. It's just there's going to be some sort of change in the motion. All right, so balanced and unbalanced forces. Two forces equal in size and acting in opposite directions on an object. The object stays still or continues to move at the same or constant speed and in the same direction. So remember, when forces are balanced, there's no change. It's either going to stay sitting still or it's going to keep on moving just like it was before. So example 1 is a soccer ball sitting on the ground, not moving. Gravity and the normal force are equal and opposite. So gravity is pulling down on that ball towards the center of the earth. The ground is holding the ball up and not letting it get sucked underground. So they are equal and opposite, so the ball stays still. So we have several examples here. So we have this race car. It is at rest, so the forces are balanced. This baby in the middle of the road for some reason is also at rest, so it is not moving. Its forces are balanced. This cup and saucer, we saw this last week in last week's video. It is also at rest. So this person on this motorcycle, they're moving in the same direction at the same speed, so everything is balanced. And this horse, same thing. He's running to the left at a certain speed. He's going to keep doing that because his forces are balanced. So now we'll talk about unbalanced forces, and we did a little bit of this in class. So two forces that are unequal in size and opposite in direction. So this always causes a change in motion in one of these areas. So either the position, the direction, or the speed of the object will change. So it might move from here to here. It may be going right and it turns and starts going left. It may be going really slowly and then it speeds up. Something's going to change. So for example, the moon orbiting the Earth is unbalanced forces because it is constantly changing directions and position. So it is going around the Earth, so it is constantly changing direction, and it is also constantly changing its position. And that's also why we have the different phases of the moon in the sky, is because we are looking at the reflection of the Earth, reflection of the moon in different amounts of sunlight. And then try to think of 2 more examples of unbalanced forces that maybe you've seen or that you can think of. So balanced and unbalanced forces, so these are more unbalanced force examples. So here we have 20 newtons to the left, we have 10 newtons to the right, so the amount or the magnitude of the forces are not equal because 20 and 10 are not the same number, and they're going in opposite directions. So this box or this orange rectangle is going to move to the left. These race cars, again, are going around a track in an oval, and so they are constantly changing direction. If they're trying to win, they're probably changing their speed quite often too, because they're going to try to go around each other. And the moon, like we said, it's going around in an elliptical orbit, and so it is constantly changing directions and positions. So here we have 2 horses pulling against each other. Horse 2 is the stronger of the 2. Maybe he's younger, I don't know. So these horses are going to move to the right because horse 2 is just stronger. And please don't try this example at home because this kid in the middle is probably going to hurt. So the student exerting the strongest force will determine the direction of movement. So before we pull our friend's arms off, if the girl is stronger, then the boy in the blue shirt is going to move to the right. If the boy is stronger, then he's going to move to the left. But yeah, don't do this. Don't hurt yourselves. Okay, so net force, and this is what we talked about last week, is the overall forces acting on an object and is measured in newtons. So just like we measure distance with meters or temperature with degrees, force is measured in newtons. That's just the unit. So here we have 2 people on ice skates. This person is moving with 3 newtons to the right. Here, this person is moving with the force of 2 newtons to the left. So what direction are these people going to move and why? So we know since they are moving in opposite directions, we need to subtract. So 3 minus 2 is 1. And since the person going to the right is stronger, then they are going to scoot to the right with a force of 1 newtons. So this person on the left with the bun in her hair, like me, is going to win. So think about it. Bumper cars. I don't know if there are bumper cars in China. I'm sure there are somewhere. So bumper cars are an example of unbalanced forces. And so when 2 cars run into each other, the one that has the most force will continue forward while the other is bumped away. So you're in these little cars, you're driving, and you hit each other, and one of them goes backwards and one kind of keeps going. Not that I would know that. I always was in the car that got thrown away. How could you predict which bumper cars will win in a collision? Describe an experiment you could do that would help you know whether the weight, speed, or direction of the cars have the biggest effect on collision outcomes. So just kind of think about that. How could you predict when the 2 bumper cars hit each other, which one is going to move out of the way and which one is going to keep going? What do you think? If Miss Amanda's driving it, she's probably going to get moved out of the way. I think I never went fast enough. Okay, so let's check on this too. So we're going to determine which statement below represents a balanced force and which one represents an unbalanced force. And we would drag and drop, but we can't do that. So we're also going to think about why the forces are balanced and why they are unbalanced. So which one would be balanced? So one tug of war, I should say, of war, team pulls harder than the other team. So one is pulling harder than the other team, so they have more force. So these are going to be unbalanced forces. And again, the color kind of gives it away. So if one team pulls harder, then it's unbalanced. This one, 2 teams are playing tug of war. Each team is pulling with equal forces in opposite directions. Equal forces, opposite directions, we subtract. Your net force is going to be 0. Remember, if it's a net force of 0, then it is balanced forces, and nothing is going to change. Neither team is going to win. So how do unbalanced forces cause a change in position of a direction? So if we are skiing, and this would not be me, I'm never ever going to go skiing in my life. So a skier is at the top of a hill, and that is balance force because they are just standing up there, not doing anything, just looking over the edge, just standing up at the top of the hill. Another skier bumps him, causing him to fall down. It's mean. And this is an unbalanced force caused his position to change because maybe he was standing upright and now he's fallen over, or maybe he was here and the guy bumped him and moved him over a little bit. So he's just in a different space than he was before. And so think about this. In your own words, how does an unbalanced force cause a change in position of an object? Because remember, position is just where something is located. So how do unbalanced forces cause a change in direction of an object? So again, we have the skier at the top of the hill, and then the skier decides to point her skis, she decides to point her skis down the hill and push off, which is an unbalanced force. And this balanced force caused her a change in direction. So she was standing still, she started to push off, and now she's going down the hill. So she is moving in a different direction than she was before. So again, in your own words, think about how does an unbalanced force cause a change in direction of an object? Because position and direction, two different things. And then lastly, how do unbalanced forces cause a change in the speed of an object? So a skier is at the top of the hill. You're all about skiing in this example. And at the beginning of a race, as he flies down the mountain, he picks up speed. Because as he goes more and more and more, he's getting more gravitational potential energy. Maybe you've heard that before. So he's getting more energy as they go down the hill, and they're going to get faster and faster and faster. And so this unbalanced forces has caused him to have a change in speed. So in your own words, think about how does an unbalanced force cause a change in the speed of an object? So think about this. Isaac Newton's third law of motion, which we will get to in a couple of weeks, states that for every action, there's an equal and opposite reaction. That means if a car collides with a brick wall, the same force pushes back against the car. And that's why the cars that drive into brick walls don't look so good. So if you were about to run into a brick wall, would hitting your brakes help lessen the force of the collision, even if you knew they couldn't completely stop you? What do you think? Why or why not? So do you think that hitting the brakes would help because it would increase or decrease your acceleration and therefore increase or decrease your force for impact? So if you know you're going to run towards this wall or you're definitely going to hit this wall, should you hit your brakes, would that help have a lesser amount of force when you hit the wall? What do you think? Yes, it would. All right, so read each situation and decide if it's an example of a balanced force or unbalanced force. So we will look at these together. So an airplane in flight at cruising altitude. So the airplane is flying and it is just kind of coasting along at a certain height at the same speed. You think that is balanced or unbalanced? So at a certain height, just going along at the same speed. That would be balanced. And that is also when the pilot allows you to take your seatbelt off and walk around inside because it's pretty safe. It's easy. All right, so two women lifting a box into the back of a truck. So would that be balanced or unbalanced? They're lifting the box and putting it inside the truck. So that would be unbalanced. So they are changing the position of the box from the ground up into the truck, and then changing the direction because it is going up. Why did my camera just do fireworks? I'm so confused. Okay, moving on. A skier going down a mountain. Is that balanced or unbalanced forces? We literally just had this example. That would be unbalanced because they are picking up speed as they go down the mountain. Their position is also changing. They were at the top of the mountain. Now they're down towards the bottom. So yeah, they're definitely unbalanced forces. An earthquake releasing energy at the fault line. Do you think that is balanced or unbalanced forces? It's going to be unbalanced because the ground was steady, nothing was happening, and then it starts moving. I've been in one earthquake in my life, and it was interesting. A book sitting high upon a bookshelf. So if you have a book up on top of a bookshelf, is that balanced or unbalanced? That's going to be balanced because it is up on top of the shelf. Nothing is changing about its movement. It is not falling off the shelf. You're not picking it up. It's just sitting there. Stuff that's sitting still, balanced forces every time. And then two people pulling opposite directions on a rope with the same amount of force. Is that balanced or unbalanced? And again, we've talked about this one several times. If it's the same force, opposite directions, nobody wins. Balanced force. Okay, so we are going to describe these. Just kind of think about these questions. Describe balanced and unbalanced forces the best you can. And then identify and describe how unbalanced forces cause a change in position, direction, and speed of an object. So just make sure you know how to answer both of those. Do you still have any questions about the essential questions at the beginning of the lesson? If so, just kind of think of those. You can always go back and rewatch the video if you need to. And if not, good for you. This was a really short video, especially compared to last week. If you need anything, you can pause, rewind, and let me know.